CH3. So it is designated by 290. The same nomenclature. Okay. So inorganic compounds are designated by 7 series. Okay. 7 series, whereas 17 represents the molecular weight. So 7 series, next 2 digits represents the molecular weight of that refrigerant. So for NH3 it is 717. H2O, so it is 7 and the molecular weight of H2O 18. Okay. So for air, so that is nothing but oxygen. Okay. Then carbon dioxide, so designated by 744. Similarly SO2, so 764. So last 2 digits represents the molecular weight and 7 series represents the inorganic. Unsaturated organic compounds, so represented by 4 digits. So last 3 digits represents the same nomenclature. So C2H4Cl2. So the number of that refrigerant is 1130. Then C3H6. So number of carbon atoms are here 3. Okay. So it comes 2. So F is not there, 0. So H is 1 more than the actual H. Okay. So that is H6 is there. So 1 plus 6, 7. Okay. So unsaturated organic compounds also follow the same nomenclature with 4 digits. Next, the vapor compression refrigeration, we have already seen the total syllabus in vapor compression refrigeration. Just one topic I have not mentioned. Let us see that one. So this is a single stage vapor compression refrigeration system with liquid to suction heat exchanger. Okay. So by installing a heat exchanger, so in between the condenser and the expansion valve. So the liquid suction heat exchanger is in between the expansion valve and the condenser. Okay. So by this way we can able to include subcooling and also superheating of the refrigerant. So here subcooling is taking place before the refrigerant goes into the expansion valve. Then after the evaporator, okay, whatever the refrigerant that is passing here, okay, that will be slightly superheated, because always dry compression is preferred. So this LSHX, that is the liquid to suction heat exchanger, is mainly used for dry compression or otherwise with some superheating at the suction of the compressor and also subcooling. Okay. So with this we can able to increase the refrigeration effect and also the CO. This is the TH diagram showing this heat exchanger here. So 1 to 2 is compression, then 2 to 3 is heat rejection in the condenser, and 3 to 4. So 3 to 4 subcooling is possible by installing a heat exchanger after the expansion valve and before the evaporator. Then 4 to 5 is the actual expansion in the throttle valve, and 5 to 6 is the heat or refrigeration effect produced in the evaporator, and 6 to 1. So that is the superheating possible with this installing a heat exchanger. So in this case here, if you see the diagram here, how the heat transfer takes place. Okay, how subcooling is possible, how superheating is possible. So that is shown by the curved line. So the same thing is shown in pH chart. So in this, whatever the heat that is taken away in the condenser, okay, by subcooling is given out for superheating. Okay, if you see the heat transfer between the subcooling and the superheating, so we can equate the heat, okay, that is cooled in the condenser and the heat removed in the condenser, the heat added after the evaporator. Okay, so with this we can see specific heat of the liquid into T3 minus T4. So that is the cooling taking place from 3 to 4, and Cp of vapor into T1 minus T6. Okay, so 1 to 6 it is heated. Okay, if you see here, since the specific heat of the liquid will be always more than the specific heat of the vapor, so from that we can say that T3 minus T4 will be always less than T1 minus T6. So what is T3 minus T4? That is the subcooling. So whereas T1 minus T6 is nothing but that is the superheating. Okay. So with that we can say that T3 minus T4, that is the temperature difference in the subcooling, will be always less than that of the superheating at the suction of the compressor. So degree of subcooling will be always less than the degree of the superheating. So with this you can find out the effectiveness of the heat exchanger also. So that is the mass of the refrigerant in the specific volume of the refrigerant. So this is the one given by Grindley. He showed that, so by installing a heat exchanger we can able to subcool the liquid refrigerant, and also we can superheat the vapor refrigerant also.